All right, so here is the last page of our review. And so we're going to start with rationalizing. So on this first one, what we're going to do here, so you got a square root of 7 on bottom, so you want to rationalize that by getting something that is a perfect square in the denominator spot. So what we're going to do is multiply by square root of 7 over square root of 7, and that should help us out here. You do have to do it on top and bottom, or else your expression would not be equivalent. So let's see, we're going to get 5 square root of 7 on top. On bottom, we're going to basically get the square root of 7 squared, or 49, however you want to look at it. It doesn't really matter because the radical will cancel out that power there. So we're going to end up with 5 square roots of 7 all over 7. Now, a common mistake students will make is they try to cancel out those 7's, but one's a radical and one's not, so they're not the same, so you can't just cancel them out. Okay, our next one here, same idea, so we're going to multiply by square root of 3 over the square root of 3. And so on top, we're going to get 9 square root of 3 all over the square root of 9. Or 3 squared or whatever, so you can see I did it a little differently than the last one. It makes no difference. So then I get 9 square root of 3 all over 3. Now, once again, don't try to cancel out those 3's because the radical 3 is different. But what is going on here is I got 9 and 3, and those are truly 9 and 3, so I can go ahead and reduce those. So that reduces to a 1, that to a 3. So our final result is just 3 square root of 3. So you actually don't even have a fraction any longer. Okay, so our last one that we're going to look at is where the denominator is a little bit more complicated. To get rid of the radical, you're actually going to have to multiply by the conjugate in this place, in this case. So the conjugate here is going to be 5 minus square root of 2. And then so on bottom, we'll do 5 minus square root of 2. And so here, you could distribute the 6, but typically we just kind of keep it right here. So 6 times 5 minus square root of 2. Okay. And then on bottom, we are going to go ahead and FOIL this. And so 5 times 5 is 25. 5 times minus square root of 2 is going to be minus 5 square root of 2. Square root of 2 times 5, that turns into a plus 5 square root of 2. So those are going to cancel each other out in a second. And then square root of 2 times a minus square root of 2 is going to be minus. You can put 2 squared, or you could put a 4. It doesn't really matter. We'll get the same result at the end there. And so, like I had mentioned, these cancel out. Okay. And so let's see, you still have the 6 times 5 minus square root of 2 on top. And then on bottom, you're basically going to have, let's see, 25 minus 2, which we'll go ahead and finish that off, and then we're done. So let's see, 25 take away 2 is 23, and there we go. All right, so our last part that we're going to look at here is going to be to perform the indicated operations. Write your answer in the form a plus bi, so that's complex form. Okay, so you have your real part, then you have the imaginary value second. All right, so these first couple ones really aren't too bad. So if you recall, when you square root a negative, that's where the I comes in. So you're going to get an I, and then also the square root of 36 is 6. So it's going to be 6I. There you go. That's it. Okay, so on B, you get an I, and then you can break up the square root of 45 into a 9 times 5. And so then the square root of 9 is 3. So we're going to go ahead and write that as 3i. Looks nicer to write it like that instead of I3. So 3i, and then you still have radical 5, square root 5. That's it for that. Okay, on this next part, we want to be careful. On C, this one's easy. You're just going to subtract this right here and combine like terms and put it in complex form, and that's it. And then the ones below, you're actually multiplying together. So we're going to want to be a little bit more careful. So we want to notice the difference. I have a subtraction between the two here, they're getting multiplied on those last two down there. So once again, complex form, I want it written like this. So first things first, I'm going to go ahead and distribute that negative. So let's see, I get negative 3 plus 5i minus 8 minus 7i. And so now it's just time to combine like terms. So put the real part first. The real numbers are the minus 3 minus 8, which is minus 11. Then the imaginary part of it is the plus 5i, the minus 7i. So it's going to be minus 2i. There you go. All right, last two. And we are going to be foiling these. And then just put them in the form a plus bi, where b is just, a and b are just, real numbers that we're familiar with. Okay, so let's see, we're going to multiply the 2 by both of these. So we're going to get 2 minus 10i. And then we're going to multiply the 3i by both of these. So 3 times 1 is a plus 3i. 3i times a minus 5 is going to be minus 15i squared. So if y'all remember, I squared is equivalent to negative 1. That's what I squared. I squared is going to be equivalent to negative 1. So this right here is actually going to turn into a plus 15, because minus 15 is getting multiplied by essentially negative 1. So let's see what we have here. So we're going to have 2. I can go ahead and combine these together. That's going to give me a minus 7i. And then this actually turns into a plus 15 because of the I squared. And so then the last thing we want to do is combine these two right here, which will give us 17 minus 7i. And there you go. That is it. Okay, last one, you'll notice that these are conjugates. And this can be useful for something that we didn't really actually cover in the notes. And the reason why is we didn't need to go that far to support what we're going to be doing in college algebra. But it's kind of nice what happens here. So you're going to multiply these together, and we'll actually end up with just a real number at the end, not even a complex. So let's see, we're going to multiply 5 by both of these. So 5 times 5 is 25. 5 times the plus 6i is going to be plus 30i. Then we do the same thing here. We multiply by negative 6i, so that gives us minus 30i. And then we get a minus 36i squared. And so the middles cancel out. So we're left with 25. And then right here, this actually turns into a plus 36 because of the I squared right there is multiplying by negative 1. Add that together, that's going to give us 61. And there you go. And that's what we're looking at. All right, that's the end of the review.